Okay, this is my solution to the fly and the spider. We were asked to find the distance the spider had to walk to get to the fly and what the shortest path was. So I did I did a lot of things before I think I have the right answer, and I'm still not 100% sure. So I made two graphs to represent the coordinate of each fly and spider. So it says that the spider is 5 feet up from the floor. So here's the floor, and you go 5 up, and then it's 2 feet in from the southeast corner. So if the corner is at 10, we go 2 in. So our coordinate there would be 8, 5. And then for the fly, it said is on the north wall, but we have to remember the north wall is still only 8 feet high. He's 4 feet up, so starting at the 0, go up 4, and then he's 4 feet in from the northwest corner. So I still gave me a coordinate of 4, 4, and I still kind of doubt that, but I'm gonna go with it. So then I used those coordinates. So then thinking about what the spider would have to do to get to the fly, I visualized it in my own room. So the spider is up on the wall, so he's going to have to crawl down to the floor and then go from where he ends on the floor over to the baseboard of the fly. But he's not going to go this way. He's going to go diagonal across the room. So it would put him about here. So I found the distance between here and here using the distance formula, and I came up with the square root of 32 is that distance, but then I had to account for the spider having to come back down 5 feet and then go up 4 more feet to reach the fly because it's 4 feet up on the wall. So I added 9, so it gave me a distance of 14.7 feet. I also calculated how far they would go if they just went in straight lines rather diagonal. And I came up with 27, I believe, because they would have to go back into the corner, the distance of that 12-foot wall, plus the distance over to get to the 4 feet so it would be, I'm 6 units here, sorry, I don't know how to subtract apparently. And then remembering that he's 4 foot down, so you'd add another 4 feet in. So let's see, so that would be 2, 9 and 6 is 15. So I guess it's 17, not 27. So clearly that's not efficient. So then the second problem says the fly now has moved. So the fly moved to this coordinate here, or it would be this coordinate here on this graph. And so you would have to redo that line from here to here. So that's what I did, and I came up with the square root of 41 because I used the coordinates 8, 0 and 3, 4. That was about 6.4, and I added on the 9 again for the spider to come down and then go back up the wall. So I had about 15.4 feet. Then our third problem was now about honey, and there's honey 2 feet up the wall and 2 feet in from the northwest corner. So here's the honey right here. And then the fly is now positioned at the midpoint of the south wall, smells the honey, and flies directly to it. So remember, the south wall is only 10. So your midpoint would be 5 and 4 because the wall is only 8 feet tall. So then I just made a line from, can't hardly see it, from here to here, and I used those coordinates. So I used the coordinates 5, 4, and 10, 2 to help me find the distance that the fly would have to fly, and it was 5.4 feet.